Good afternoon, class. Today I am going to talk about modes of radioactive decay. Modes of modes of radioactive decay. All right. Decay will write this side because it is not coming in the screen. Modes of radioactive decay. So basically, in radioactivity, there are three types of radioactive decay. We know them as alpha decay, beta, and gamma. 1, 2, 3. So three types of radioactive decay or disintegrations we have. In this class, we are going to learn about these three types of disintegrations, see one or two examples in each case, and also we will discuss about group displacement law. So let's begin with alpha disintegration. What happens when alpha disintegration takes place? Let's take an example. Uranium 92 238 disintegrates, giving a helium, that means helium atom, that means alpha particle. And what we'll get here? The daughter element. The daughter element that we'll be getting will be, just try to balance. This is 92, we already have 2, so here we'll be getting an element having 90, thorium probably, since here already 4 we have, here it is 238, 4 we have, so it will be 234. So you will be getting a daughter element having atomic number 90, mass number 234. So what is happening here? When an alpha particle is emitted, the daughter element that we get here, its atomic number will decrease by 2 and its mass number will decrease by 4. Initially it was 238, now it is 234. Initially atomic number was 92, now it is 90. So this is called alpha disintegration. Next, we will talk about beta disintegration, second one. So when a beta particle is emitted from radioactive element, usually the new element formed will have atomic number which is greater than that of the original element by 1. Let's take an example. Here also uranium. Uranium 92 239. It is going to give you a beta particle. So beta particle -1 0. This is the charge. We can write -1 E0 also for beta. Now we'll drop this. So this is beta particle plus you will be getting some other daughter element. So 92 -1, so it will be 93. You will be getting an element having atomic number 93, probably NP 239, because here it is 0. So when we write this kind of equations, what we need to understand is we should know how to balance. 93 plus -1 is 92. So here we have 92. So this side we have 239. So 0 plus 239, it is balanced. So basically, when a radioactive element emits a beta particle, the daughter element which forms will have atomic number which is 1 more than the parent. Here it is 93, here it is 92. There won't be any change in the mass. Alright. Now let's see quickly gamma disintegration. Basically, gamma disintegration is a secondary disintegration, because gamma disintegration takes place only after the disintegration of alpha and beta particles. So gamma rays are electromagnetic radiations, and they don't carry mass and they don't carry charge. And we also say that gamma disintegration is actually a secondary effect. Secondary effect. Why it is called secondary effect is because when an atom emits alpha and beta particles, it usually goes into excited state. So to release this energy of the excited state, it is going to give radiations in the form of gamma rays. Okay, so here we don't have any examples for gamma radiations. Now we will see group displacement law. Very important, group displacement law. Group displacement law. So group displacement law tells us what happens to the daughter element, what happens to the position of the daughter element in the periodic table when alpha particle, beta particle and gamma particles, for example, are emitted. Very simple. So let's take few examples. When alpha particles are emitted, what will happen? When alpha particles are emitted, what will happen? Let's take example of a radioactive element, polonium, which is having atom number 84 and mass number 215. So this polonium is going to give you a helium atom. So helium He24 plus He24 plus you will get another daughter element also. It will be probably 84 plus 2, so you will be getting 82 element with the atomic number 82, probably lead, Pb 211. So 211 plus 4 will be 215, 82 plus 2 will be 84. Alright, so what is happening here is, what has happened from 84 it has become 82. So atomic number has decreased from 84 to 82 by 2 units. So when it is like this, we can say that when alpha particle is emitted, the daughter element will be having position 2 groups to the left in the periodic table. That's very important. And this is called group displacement law when alpha particle is emitted. Let's see when what happens to the position of daughter element when beta particle is emitted. Let's take the example. Same equation. Pb 82 211. So we let it to give a beta particle -1 E00, and what we will get? So here we have 82, probably it should be 83. So you will be getting an element with 83 atomic number, that would be bismuth with 211 as the mass. 211 as the mass. So what is happening here is, from 82 the mass number atomic number has changed to 83. That means it has increased. Okay, it has increased. It means that when a radioactive element emits a beta particle, the mass number, the atomic number will increase. That means there is a change of one group to the right hand side of the periodic table. Is okay. Similarly, we can talk for emission of a positron. Emission of a positron. So what will happen? Emission when positrons are particles like electrons, but their charge will be opposite to that of electrons. So let's see example. Magnesium 1223 gives a positron, so +1 E00, this is a positron, plus what we will get? This 12, already +1 is there, so probably it will be 11. So 11 means sodium, 0 plus 20, 0, okay, so this will be 23. So you will be getting a daughter element having atomic number 11 and mass number 23. So what is happening here? Emission of a positron usually shifts the position of the daughter element by 1 group to the left. One group to the left. Previously it was 12. Now you have 11. Is it okay? Next is electron capture. Electron capture is nothing but simply just for understanding, it is electron. It is addition of electron. Addition of electron. Okay. It is also called as K capture. CAPTURE. Let's take example. Electron capture. Calcium 20, 40, -1 is 0. So what kind of daughter element you will get? So 20 minus 1 will be 19. So element having atomic number 19 probably is potassium. It will be 40. 90, 19, 40. So here position, if you see in the periodic table, calcium will be in group 2 and potassium will be in group 1. So what has happened? During electron capture, the position of the daughter element will be shifted one group to the left. Is it alright? That's all with the group displacement law. Hope you all understood this. Thank you so much.